For the process of developing our particle effects, the first thing we need to do is kind of prepare the elements that are going to be important or more important for the effects. The main thing is definitely the emitter. That's an obvious one. But the second thing, almost as important, is going to be the robot, which is going to be blasted by the particle blast. So we really need to prepare the geometry properly so it can interact in a more effective way with the particles. So let's have a look at that. I'm going to hide everything else. Let's turn off everything else and the light. We don't actually need the light. And let's just start preparing the geometry of the robot. I'm going to create a geometry container. And it's going to be called prep robot. I'm going to change the color to green. It's kind of sort of a development thing. And let's get the robot first. So let's go object merge and get exactly the robot that's being rendered here. So we have the output node. Let's put it here. Get robot. Pin this and yeah. So we have the robot geometry. If we middle mouse button over it, you'll see this is composed of 18 different packed alembics based on 80 different materials. This is not very useful for us to interact with in terms of geometry. So let's apply an unpack. There we go. And now we have all these groups and attributes, but we don't have the shop material path. We do have 18 different names and 18 paths. If you want to transfer the shop material path to your geometry, then make sure that you have that option here, shop material path. That way you'll find that we do have the shader applied. You can disable the shader in the viewport as well. So now that we have actual geometry, will this work? Let's go to the first frame. So this is the first frame. And why wouldn't this work? Let's try to make it more visible. The reason why this probably wouldn't work is this. So the issue is that this is not a continuous mesh, and it would be much better for us to have effects of particles sliding through the surface, hitting the surface and all that. It'll be better if we have kind of a continuous mesh, a watertight mesh of the robot, instead of having all these different tiny little pieces. Some of them don't even have thickness and all that stuff. So when you want to do that, the first thing that comes to mind is most likely convert or VDB from polygons, right? Okay, let's increase the resolution 0.01. This seems good enough, right? Let's slide it through and let's convert this back to polygons. Okay, when we convert this back to polygons, you'll see that on the fingers, we don't have a lot of detail, and we have this type of situation here. We can look for a frame to see if there's a better frame. I guess we were at the only frame where they're actually not connecting to each other. But overall, we don't have a lot of detail. This is probably more than enough though for what we need. Shift W just so we can have a look at the wireframe. This could work. Of course, if you go to frame 1, your hand is going to be just one closed little thing. So we're kind of trying to recreate the mesh, and then we can deform the mesh based on the animation. But the first thing we need to do is make sure that we actually have a good mesh. And the best frames for that is somewhere around here. His legs are a bit wider, more wide from each other, and we have that issue with the fingers. Let's look for that magical frame. But as you can see, it's still problematic. We can try and give it a bit more detail. 0.08. Now we have a bit more detail. Still grabbing. Those fingers are still connecting, and this is the magical frame where they don't connect. And at this point, I think we could actually go with this. Okay, so let's use this frame. First things first, I'm just gonna delete this. Let's use a time shift. And this is the frame that we're gonna be considering. Frame 1084. I just used Control Shift and clicked on the parameter, and that just cleans up the channel. So we could use this. So now we have this geometry. We may not need as much geometry as we have here. This isn't very optimized, but it's not too heavy either. You can still try to poly reduce this. It can speed up things a bit later on. So we have our fingers, we have legs and everything. So this will work. Now, the next thing we will have to do is we need to transfer the animation of this. So that's pretty easy. We're going to use a point deform. And this is what we want to deform. This is the rest pose. And this is the deform pose. So now we can scrub through and we do have our animation based on this geometry. I'm thinking ahead and remembering that for the purposes of some of the effects, we might need to come back to this and not go with a poly reduce, maybe work with a remesh instead. Let's give that a try. So we have this. Let's remesh it. Of course, with not this target size, 0.01. Okay. This gives us more of a uniform point position and edge length on the topology of the model, and this is probably better than going with this option. Yeah, so let's use the remesh instead of the poly reduce. And yeah, I think this is going to be useful for a few other situations as well. And I think we have enough detail. Okay, so now we have a watertight mesh being deformed by the original mesh. There are some things you can adjust on the point deform that may help with some of the imperfections or some of the distortions that are happening here and there. But it's up to you to give that a try. You can try to reduce the maximum points or reduce the radius or increase the radius. Let's say it can go up to 0.5 and use 128 points. This kind of tends to smooth things out, but it may cause that things that are very far away are affecting other things. But yeah, definitely give that a try. Sometimes if you want things to be more precise, the tendency will be for us to reduce the maximum number of points so that it doesn't grab much. It gives you sharper edges. If you want to smooth that out, you should probably just apply a smooth. Let's go with the smooth, and yeah, that smooths things out a bit. Maybe not enough, and maybe then because the fingers tend to get too thin, you may want to compensate that with a peak. Find the value that works better for you. Yeah, I don't think this is worth the trouble, but to be honest, it may be a good idea because it's better to have these smooth angles, and because our particles are going to be sliding through the surface, and it may be a good idea. Okay, this will give us less issues on that, maybe 4. Very small number of points tends to give us sharper details. And this is probably the worst frame. Just trying to see if we have the same type of volume. Yeah, I think this is a good balance, having some smoothed out some of the sharper artifacts and kept pretty much the same type of volume. Okay, so I'm going to go with this one. Okay, so this will be the mesh that we're going to be using for collisions and all that stuff. So let's put here a collision source and two nulls. It's going to be out robot remesh anim collision, and then we'll have the VDB. VDB. Of course, we do need, if you have a look at this, it's terrible. So we do need to improve the volume voxel size to 0.02 or something, or maybe even 0.01, just in case we're gonna. Now, even though this doesn't take too long to update, it's a good idea to cache because it will save us some time when we're doing some particle simulations down the line. So I'll add a file cache. This is a new node from Houdini 19, or it is a node that's been updated. It has some really cool features, and right now I'm going to make sure that we add some proper naming to this. So let's say robot remesh name collision. We can put this after or before, but I'm going to put it before, and then I'm going to turn on load from disk. So the way this is going to work is it now takes into account different components, including the version, to build up the folder structure and build up the file name. You can check the file name here on the advanced tab. You have your path, and you can always check what's it gonna be. The base name for me, I'm just gonna use the OS $OS, which is gonna be inheriting this name. And for the base folder, I'm going to leave it as is. Also, version 1 is fine. And I'm just going to press go to caching, save to disk. There, so now it's done. I have load from disk enabled. If you have load from disk enabled, this new icon appears. So if I have it disabled, it doesn't appear. And now the playback will be much faster, as you can imagine. I'm not going to cache the VDB volume right away because we're not going to be needing it right now. Later on, we'll probably come back and cache this one as well. One thing I want to point out is what's happening on the collision source. When you go up to the peak node and your middle mouse button, you'll see the only attributes we have are point, position, and aim. After you apply the collision source, you'll see that we now have velocity, which is an important attribute to have when you're going to be applying this for collisions. And that's the only attributes that we're actually caching out. On the VDB, we only have pretty much the collision VDB. Okay, so now we have a version of the robot mesh that's more appropriate for interacting with the particles and the particle effect that we're going to be developing. And we're ready to move on to the next lesson.